Hey guys, fun today listening to my voice and watching a video on the notes since I am not able to be with you guys the next few days. Today we're going to be covering theoretical and experimental probability, and I did include a little bit of a challenge, a little bit of a geometry connection later so that you can try that also. So some of this you may be familiar with, some of it you may haven't done in a while. I think it's good review for everybody. And then Monday, you guys will work on compound probability. And again, that would be something that maybe you haven't done in a while also. So just some good review days as we finish up the year. So if you guys could have your notes ready to go, we're going to get started. In this problem, to start with, we're just going to review some main vocabulary that we talk about when we're referring to probability. So I'll just highlight a few things. An outcome in probability is the result of a single trial of an experiment. And an event is a group of possible outcomes. So, for example, when you have a dice, they call it a number cube, the possible outcomes are 1 through 6. So, if we wanted to write all the possible outcomes for each event described below, you would just list those possibilities. So, for example, rolling an odd number, we know that that would be a 1, a 3, or a 5. So those are the outcomes in that event. Same thing with rolling a number here, a number 4 that is divisible by 3. So that would just be 3 and 6 in this case. So anytime you're writing the outcomes, you're specific to the event that is listed. We also want to talk a little bit about probability in general. When you're asked to find the probability is the likelihood that a certain outcome will occur. And probability of an event ranges from 0 to 1. So we call this the probability number line. Of course, 0 would represent it's impossible to occur, and 1 represents it is certain to occur. And of course, you have everything in between. Normally, we would write it as a fraction, a ratio. Occasionally, you'll see it written as a decimal or a percent. But for our purposes, I'd really like to keep it as a fraction unless they specify otherwise, okay? We have a little bit of matching here for vocab, giving you a situation to describe its probability from likely or certain to impossible. You can do that on your own if you would like to, but I'm not going to do that today. We're going to just kind of move right along here with probability. So let's get going. So if you guys will turn to the next page. Again, I've got a little bit of vocab here. So when we talk about all the possible outcomes that are equally likely, that's important, we can find the theoretical probability of that event using this formula. And when we find probability, we write it in this notation. So it's going to have the P in front, which stands for your probability. And then whatever event is that you're trying to find would go in the parentheses. And then our ratio would be the outcomes out of the total number possible. So, for example, here we're going to find theoretical probability. Here we have 8 planets in our solar system, and they want us to write the theoretical probability that you'll select a planet that is further from the sun than Earth. So I'm just going to mark a line here. So we have Mars, Jupiter, Saturn, Uranus, and Neptune. So that would represent 5 out of those 8 planets. I know that some people might consider Pluto a planet. I think they go back and forth on that. I feel like they're always changing their mind. So we'll just use what's given here, not debate that today, okay? You know, theoretical probability, of course, is going to be what we theoretically would expect to occur based on the outcomes possible. Does that always happen? No, but just keep that in mind. Now, sometimes when we talk about probability and theoretical probability, we also talk about the complement of an event occurring. So the complement of an event consists of all the outcomes in the sample space that are not in that event. So basically, it's what isn't going to occur. So if we look here at this example, we are finding the probability here of what happens when you have not drink A. So in a taste test, 50 participants are randomly given a beverage to sample, and it tells us the number of each sample there. But it says, suppose the number of samples of drinks B, C, and D were increased. So what happens to the probability that they don't drink A? So we can see here that drink A has 20 samples versus the others, which have 10. So if they were to raise the other samples of the drinks, then obviously drink A is going to go down. So the probability that you would pick something that is not drink A would increase. So I'm just going to write that out real quick here. So the probability that it is not drink A will increase if, sorry, my handwriting, wow, okay, will increase if the drinks B, C, and D increases. So here they didn't really want us to find the probability that it's not drink A. I guess we could do that also, but we could also just explain that the probability of the others would increase, if you get my meaning. If we wanted to, we could add up all the samples and find out the probability of drink A, but they're changing the samples anyway. So going on from there. Yeah. Now, here's something else that is an interesting thing when we talk about probability, and that is odds. So I'm going to probably do that in the next video. Actually, what the heck? Let's keep going. Maybe I can get through all of it in the next 6 minutes or I get cut off. Anyway, so the odds describe the likelihood of an event as a ratio comparing the favorable outcomes over the unfavorable outcomes. So this is where odds is different than probability. And you hear a lot about odds when you're thinking of Las Vegas and things like that. And it really isn't the same thing as probability. And people sometimes, I think, get those two confused. So the main difference here is taking the number of unfavorable outcomes in the denominator versus with probability, it's out of the total possible outcomes. So slightly different. And you can have odds in favor of something occurring and you can also have odds against something occurring. So if we look here in example 3, we want to find the odds. So what are the odds against the spinner landing on a number that is less than 3? So we're talking about against. So we're going to take the unfavorable outcome over the favorable outcome. So first of all, let's look at our probabilities here. Let's look at favorable, versus unfavorable. And we'll kind of go from there. So favorable would be that the spinner is going to land on a number less than 3. So that would have to be, in this case, 1 or 2. And unfavorable would be the rest of them. So 3 through 8, basically. And since we're going against, we want the number of unfavorable outcomes over the favorable. So we have 6 values that are unfavorable, and we have 2 that work. And that can be simplified to 3 over 1. Or sometimes with odds, they write it like this with your semicolon there. Not semicolon. What am I talking about? Anyway, you get the idea. So, like I said, the odds of something occurring is a little bit different than finding the probability. So be careful on today's assignment. Make sure that you're reading the questions so you know what you're doing. Are you doing probability? Are you doing the odds? Kind of different there. Now, the other thing, the last thing I think here that we're going to talk about for today is the experimental probability. Again, something you may have had experience with in the past. Experimental probability is based on data that has been collected from repeated trials, meaning you actually participate in the event. For example, they want to know the likelihood of choosing a queen from a deck of cards. So you would actually do trials where you mix up the deck of cards and you pick a card and see if it's a queen, and then you put it back. And then you mix them up and you pick up and see if it's a queen and put it back. And you do that over and over and over again. So when you're participating in the activity, it's called experimental probability. So here we can use that to make predictions also. So suppose a manufacturer is inspecting skateboards and he observes that 2,450 of them have no defects. Well, we want to know what the probability is that a skateboard that's selected at random has no defects, and then we'll write that probability as a %. So randomly, this is what he found out of the 2,500 skateboards. So we can see that that is 0.98 if you divide those. And that would be the probability that a skateboard selected has no defects. And then we could also write that as a %. So we could write that and say, hey, 98% of the time, you're going to pick a skateboard that doesn't have any defects. All right, and just in time, because I'm about to run out of time, so you guys will have the worksheet to do on the next page. And then I also, like I said, have a little enrichment worksheet where you can see how we can use this in terms of geometry a little bit. So I wanted you to try that also today. So now you guys will have some work time to get that done, and be good. And if you get done early, that's great. You won't have homework over the weekend, but try to keep it down and work on something quietly so everybody can get finished. Okay? See you guys later.